Hi everyone, today we are discussing on welding defects in steel material. Weld joint discontinuities, interruptions or flaws in the physical, mechanical or metallurgical properties of a weld. Weld process related or joins metals or plastics together by heating them until they melt and mix. Metallurgical discontinuities originate when the materials are subjected to extreme stress or temperature to alter the physical or chemical properties to satisfy the manufacturing needs. Typical arc welding processes. Shielded metal arc welding (SMAW), which is also known as stick welding, is the most widely used process. Gas metal arc welding (GMAW) is also referred to as metal inert gas MIG welding. This process uses an uncoated continuous wire and the weld area is shielded from contamination by the gas that is fed through the welding torch. In flux core arc welding (FCAW), the shielding gases and slag are provided by the decomposing flux that is contained within the electrode. Auxiliary shielding is also used in certain instances where deeper penetration is needed. Gas tungsten arc welding (GTAW) is also known as tungsten inert gas TIG. This process uses a non-consumable electrode. Shielding gas is the primary purpose of the shielding gas is to protect the molten weld metal from contamination and high-temperature oxidation by the surrounding atmosphere. Although plain inert gases such as argon and helium may not be suitable for all applications, mixtures free with reactive gases i.e. oxygen, nitrogen, hydrogen and carbon dioxide in controlled quantities will produce stable and relatively spatter-free metal transfer. Weld quality factors that can affect the quality of a welded component include the following. 1. Design of the weld joint. 2. Selection of the proper welding process. 3. Qualification of the welding process by testing. 4. Proper preparation of the joint prior to welding. 5. Utilization of certified welders. 6. In-process monitoring of the welding to ensure quality. Arc welding defects. Most welds contain defects, porosity, cracks, slag inclusions, etc. The question is to determine if they are significant considering the application. Typically, the applicable codes or standards specify the maximum allowable limits of these types of defects in a weld based on the application. Sometimes discontinuities that may not affect mechanical properties may reduce corrosion performance. Porosity. Porosity is used to describe cavities or pores caused in the weld during solidification. Gas pockets are formed in the weld metal when they are entrapped during solidification. Incomplete fusion penetration. Although these terms are sometimes used interchangeably, lack of fusion occurs when the weld and base metal fail to adequately fuse together. Arc strikes. They are caused by the unintentional melting of the base metal outside the weld deposit area by the welding arc. It can create localized hard or soft spots, cracking or undercut, tungsten inclusions. In the TIG process, the touching of the electrode to the weld metal may cause transfer of the tungsten particles into the weld metal. These inclusions are detected by X-ray and show up as bright particles since they are much denser than the steel. Slag inclusions. One of the main functions of the flux coating in welding is to produce a slag, which flows freely over the surface of the weld pool and protect it from oxidation. Cracks. Cracks are the most serious type of weld defects that can lead to catastrophic failures in service. The effective carbon equivalent. The carbon equivalent, CE, may be considered as the main factor in estimating the need for preheat. Generally, the higher the carbon content of steel, the greater the tendency to form a hard and brittle has. The approximate recommended preheat temperatures based on CER, for up to 0.45%. Preheat is optional. 0.45 minus 0.60%, 200 minus 400 F. Over 0.60%, 400 to 700 F. Weld process related metallurgical discontinuities. Undercut. Insufficient fill. Definition. Insufficient fill on the root side, sutback, excessive concavity or convexity. Reinforcement. The amount a groove weld extends beyond the surface of the plate. Excessive, insufficient, improper contour. Excessive reinforcement. Definition. Specifically defined standard. Insufficient reinforcement. Definition. Specifically defined standard. Typically, none or up to 5% of metal thickness not to exceed 1/32, as long as the thickness is made up in the opposite reinforcement. Not applied to fillet welds. Cause. Open root reinforcement. Too little filler metal will cause thinning of the filler metal. In opposition, too hot or too wide will cause drooping of the open root puddle. Improper weld contour. Definition. When the weld exhibits less than a 135° transition angle at the weld toe. Cause. Poor welding technique. Prevention. Use proper techniques. A weave or whip motion can often eliminate the problem. Repair. The weld face must be feathered into the base plate. Overlap. Definition. When the face of the weld extends beyond the weld toe. Cause. Improper welding technique. Typically, electrode angles and travel speed. Prevention. Overlap is a contour problem. Proper welding technique will prevent this problem. Repair. Overlap must be removed to blend smoothly into the base metal. Be careful of deep grind marks that run transverse to the load. Also be careful of fusion discontinuities hidden by grinding. Use NDT to be sure. Overlap is measured with a square edge such as a 6 inches rule. No amount of overlap is typically allowed. Burn-through non-standard definition, when an undesirable open hole has been completely melted through the base metal. The hole may or may not be left open with further processing. Incomplete or insufficient penetration definition, when the weld metal does not extend to the required depth into the joint root. Incomplete or lack of fusion definition, where weld metal does not form a cohesive bond with the base metal. Arc strike definition, a localized coalescence outside the weld zone. Inclusions: slag wagon tracks, tungsten slag. Inclusion definition, slag entrapped within the weld arc craters. Definition, a depression left at the termination of the weld where the weld pool is left unfilled. Longitudinal crack definition, a crack running in the direction of the weld axis. May be found in the weld or base metal toe. Crack definition, a crack in the base metal beginning at the toe of the weld throat. Crack definition, a longitudinal crack located in the weld throat area. Crater crack definition, a crack, generally in the shape of an X, which is found in a crater. Crater cracks are hot cracks. Transverse crack definition, a crack running into or inside a weld, transverse to the weld axis direction. Root crack definition, a crack in the weld at the weld root. Underbed crack definition, a crack in the unmelted parent metal of the has. Hot crack definition, a crack in the weld that occurs during solidification. Cold crack definition, a crack that occurs after the metal has completely solidified.